Good morning, good afternoon, good evening, everybody. Let's just wait for about 1 minute before we get going on this webinar. Welcome to everybody from all corners of the world who are joining us today. I'm just gonna keep on talking about nothing for a minute whilst we wait for some people who are still joining us here in the background, and then we will get going pretty soon. Okay, I think we're probably safe to get going now. So, good morning, good afternoon, good evening, everybody, and welcome to this latest of our knowledge series of webinars run by the RAIN Alliance. I'm Aileen Ryan, the president of the organization, and it's my great pleasure to be introducing and moderating today's webinar, which is on a particularly important topic. So the topic, as you know, is converting barcodes to RAIN RFID encodings. And this is an area where we regularly see lots of challenges. And unfortunately, if you get it wrong, it can cause lots and lots of issues. So we see this as being one of the most important things that we can help our members and the wider community to get right, so that we can encourage and continue to drive increased adoption of RAIN RFID. To the extent that this is such an important topic, we're not only running the webinar today, but I also wanted to briefly tell you that we're also running a related training course in March, so in about 4 weeks' time, I guess, in Chicago, kindly hosted by Chris and TSC Printronix, and also at our upcoming Connections Summit event in Taiwan in May. So if this is a subject that you're interested in, clearly this webinar is going to help you get going. But if you need more information, more detail, more practice, then I strongly encourage you to look at joining one of those training courses, which are registration systems are available on our website already. Before I dive into introducing our speaker, I have a couple of small housekeeping things to share with you. So first of all, the question that everybody always asks is, will the slides be shared? So the answer is yes, the slides will be shared on the RAIN Alliance website pretty soon after the webinar is finished. And we will also be posting a recording once we've just done any cleanup that we might need to do. So you should see that appearing very quickly as well. So if for people who were unable to attend in person today, or perhaps if you'd like to recommend this webinar to some of your colleagues who hadn't thought about registering for it, then they will be able to view it and download it from our website. And the final piece of housekeeping is, if anyone has any questions, either during the webinar or at the end of the webinar, we will have time for Q&A. You will see in your Zoom panel, there is a Q&A tab. That's what we're going to use to track and answer questions. I see we have a question already, and I will answer that once I've stopped talking, because I'm not able to multitask like that. But if you have questions, please ask them in the Q&A. I will either answer them as I go along, as Chris goes along with the presentation, or we will hold them to the end and get Chris to answer them live for you at the end of the webinar. So with that, it's my great pleasure to hand over to Chris Brown. Chris is, I think, undisputedly one of the most knowledgeable people in our industry in general and on this topic in particular. And we are very, very grateful that Chris continues to contribute his time very generously to the RAIN Alliance and other organizations in this AIDC ecosystem for the betterment and the continued growth of our industry. So Chris, thank you very much. Welcome everybody. And Chris, I hand over to you.
Okay. Thank you, Aileen, and welcome everybody. I'm going to share my screen. We'll get started on the presentation. So as Aileen mentioned, the title of this is Converting Barcode Numbers to RAIN RFID Encodings. but I'm going to hijack the title a little bit and call it Converting Identifiers to RAIN RFID Encodings. Because as you will see, this is not just about barcode numbers, it's about all kinds of identifiers that you can convert into a RAIN encoding. First up, tiny bit about me. This is not about me, but I do need to introduce myself. So as Eileen said, I am Chris Brown. I'm the RFID Program Director at TSC Printronix. I've been in the AIDC industry, that's barcoding, RFID, biometrics. I've been in this industry. It's getting close to actually 30 years now. I'm very active in RAIN, GS1, and AIM, specifically for work groups that focus on RFID. And I have two areas that I focus on. First is RFID printers. That's kind of a no-brainer because that is one of our company's commercial RFID products, RFID printer encoders. And secondly, what this presentation and what our upcoming class are about is this topic of what should a user encode to his or her tags, and then how to actually do that. It's a complicated, difficult topic, and we need to start making it simpler and more well-known out there. So this topic is, as I just hijacked the title, it's about converting identifiers to RAIN encodings. I start with this slide. It's too much visuals, but that's part of the point here. If you just take a look around your desk, your office, your home, wherever you are, and start paying attention, you can quickly notice that identifiers are everywhere, okay? Top left, that label that's shown in the top left, that is from one of our printer boxes. I have 3 of them sitting right here. We have our own serial number scheme. That's the little barcode number that is outlined in red. That's an identifier that we use to identify each and every printer we have. A picture just to the right of that, handwritten serial number. So as I said, this is not just about barcodes, but it's any kind of identifier. The picture a little to the right of that says identifier 2211 dash, etc. That's actually from a hockey stick. These hockey sticks are about $380 now with tax, very expensive. The hockey companies have very complex return, warranty, RMA policies, so they need to keep track of the hockey sticks. So the identifier is very important. If you look at the bottom row in the middle, you'll see sort of a strange red, strange silver. I'll put my laser pointer on here. You'll see a silver cylindrical object. What the heck is that? That is actually an automotive part from Europe, and that has a barcode identifier and a human readable printed identifier on there. That's another identifier. Just to the right of that, fire extinguisher with some handwritten identifier, and so on. So the point here is not to go through all of these, but just that if you open your eyes and look around, identifiers are everywhere. And today we're going to talk about converting these identifiers into RAIN RFID encodings. Now let's start classifying these identifiers. I put them into one of 3 buckets. On the left, we have our GS1 bucket. So many of the identifiers that you are familiar with follow GS1 standards. They use GS1 numbers or GS1 data constructs, and they use GS1 barcode constructs. I have there the Coca-Cola with the UPC EAN barcode, and you may think, this guy's a moron because that's not a unique identifier. But it is still an identifier, and it's an identifier that we can convert and do convert regularly to RAIN RFID encodings. So there's the GS1 bucket. In the middle, we have the ISO bucket. The two pictures I have there, one is an airline baggage tag, non-RFID, but the numbering and the barcode construct, they're actually not from ISO, but they're registered by ISO. So that to me is an ISO data construct. There's that weird silver cylindrical auto part again. That is a European automotive part. They have used an ISO data and barcode construct to identify that. So there's the GS1 bucket, the ISO bucket, and then over on the right, we have the preponderance of identifiers that are floating around out there in the world. And those are proprietary identifiers. Back to our printer box label and our printer serial number. I don't know, 20, 30 years ago, we've determined that, hey, it's a good idea to uniquely identify each and every printer. So let's give them serial numbers. We just made up that serial number scheme. That's our own scheme. Same thing with this hockey stick identifier. It's the hockey company's own serial number scheme. So the focus of today's webinar is going to be on converting these proprietary identifiers into valid RAIN RFID encodings. Before we get into that, I just want to review a little bit both the GS1 and the ISO buckets. So when would you use a GS1 RFID encoding? Well, you would use it if you are already using GS1 standards. Coca-Cola already putting a UPC EAN barcode on their products. They're going to probably most intelligently just carry on with GS1 standards and use the GS1 RFID standards. Alternatively, if you're not using a GS1 identifier, but you look around in your ecosystem, your industry, you look at what your application is and what others trying to do a similar application are using for RFID. If everybody's using GS1, probably best to also go with GS1 encodings as well. The bottom bullet point, tag data standard, that is GS1's. It's a thick document, 314 pages, I think, very technical, but that is where you find all the nuts and bolts details of the GS1 RFID encodings. So just to recap, sorry about this jumping video, I don't know what that is. Just a quick recap. If you're already using GS1, continue on and do a GS1 RFID encoding. The same is true with ISO. If we think about that automotive part that we had, the silver cylindrical thing, that's already marked with an ISO data construct and an ISO barcode. You're going to turn that data into an ISO-based RFID encoding. I have listed here the data constructs register. In the GS1 world, you would start with this tag data standard. In the ISO world, you're going to start with this thing called the data constructs register. It doesn't answer all the questions by any means, but it's the first step, and then it points you to subsequent and additional standards, organizations, and documentation that tell you how to do your specific ISO encoding. So if you're already using ISO, or if you look around and everybody else in your industry or your application is using ISO, then it's probably best to do an ISO-based RFID encoding. Now let's get into the proprietary identifier. So I'm not using GS1 already, and I'm not using ISO already. This is the focus of today's webinar. How do I convert these proprietary identifiers into RAIN encodings? So if you're already using a proprietary identifier, this is the route to go. Or it could be that you run a business, you look around and you have some business problem and you think, RAIN RFID would help me solve that problem. but it's a problem that only I or known trading partners wrestle with. We would call that a closed loop solution, meaning only I, my company, and known partners need to decode the tag. Then this solution that we're going to talk about is also a good solution. However, before we start generating these proprietary number encodings, we need to remember the concept of tag clutter. So tag clutter, aka tag pollution, is really two problems. One we call acid rain. That is where tags from one application interfere with your application, another application. Airline baggage tags. Let's take Delta. So they have a big complex system. They want to put the RFID bag tags on the suitcases, and they want to read only their bag tags. But Chris Brown is traveling on Delta. He has a suitcase full of rolls of RFID labels, which does happen. I got, well, let's say 10,000 RFID labels in my suitcase. Acid rain would be if my tags were detected by Delta Airlines baggage tag system, and not only detected, but considered to be suitcase tags. That would crush Delta's system. It would bring it to its knees. The other problem with tag clutter we call RAIN flooding. That is where there are too many tags in a read zone for the reader to process in some limited time. Back to my Delta Airlines bag tag example. I have my suitcase with 10,000 tags, and then I have the one bag tag, so I have 10,001 tags. Delta's system is only interested in that one tag. But if all those tags are picked up, and that reader only, the suitcase is moving along a conveyor line, that reader only has, let's say, 1.5 seconds to detect only the tag it's interested. RAIN flooding is where the reader sees too many tags and never actually communicates with the tag of interest. If you don't think tag clutter is a problem, this difficult to read graph we have here, this is from a company called Race Result. They are a RAIN member, and they did a study. So they time races using RAIN RFID technology. Races like marathons, 10Ks, snowmobile races, I don't know, but all kinds of races like that. So they put a RAIN tag on each participant, and they have readers set up throughout the course. They are only interested in the tags from their system. So they have these readers set up along the course, and those readers are looking for their tags. But what they have found is the smallest y-axis increment here is 20,000. You probably can't, excuse me, probably can't see that very well. Regularly, they're getting 20,000 tags that they are not interested in. Okay, these are tags that they're not interested in. They're picking up 20,000, 40,000. Even at certain points, it got as high as 80,000. And another time it got up into the 170, 180,000 tags that they were not interested in. So tag clutter is a real problem. And if we don't do proper encodings, tag clutter is only going to get worse. So message, please do not do your own totally proprietary encoding. That's what we're going to show you today, how to take your proprietary identifier and turn it into a valid encoding. How do we do that? This is the topic today. Enter the RAIN Alliance ISO numbering system. What is the RAIN Alliance ISO numbering system? It is an ISO standards-based encoding. That means that if we use it, we can configure our readers to only look for our tags and avoid tag clutter. Okay. It is an ideal numbering system, ideal standard for encasing pre-existing proprietary identifiers, like the serial numbers we use for our printers. It's ideal for closed loop applications, where only I or a known trading partner read my tags. It is very easy to use, very simple. It's very flexible. So far, I've only been talking about encoding a proprietary identifier, but I might want to put additional information into my encoding, like the color. What color is my item? Or who's my customer? Or what's the weight of the object? And so on. I can put basically anything into a RAIN Alliance ISO numbering system encoding. It is cheap. If you're going to be doing a proper encoding, you'd need to be using some standard. Using standards generally costs some money. But in this case, the RAIN Alliance has set the fee schedule up really just to cover administrative costs. This is not a profit center for RAIN. I'm not here peddling that you buy this system. We're just trying to cover the administrative costs. I should point out that it is the RAIN Alliance ISO numbering system is sometimes called a RAIN SYN encoding. That is false, okay? I'm going to cover this more later on. Don't worry about the details of that yet. I'll get into that. But if somebody says that term, that's false, okay? Beware of that term. Some people call it a RAIN AFI encoding. I do that a lot. Technically, it's a valid term, but not many people know it, so let's not use it. Some people call it a RAIN number. Technically, again, this is a valid term. However, it gets confusing, so let's not use that. Today, we're going to use the big mouthful, the RAIN Alliance ISO numbering system. Let's get into what this really is, the nuts and bolts of it. I have listed here 5 data elements. These are the minimum 5 data elements that you will need to encode in order to generate a proper standards-based RAIN Alliance ISO numbering system encoding. I'm going to go through these. They're not going to make much sense at this point, but as we go on, they'll hopefully become clearer. So the first data element that I must encode is called the length value. This is basically a number from 0 to, I guess, 32, something, or 31. It's a number that gets encoded to your tag, and it tells a reading system how much data to read during the initial so-called inventory round of the tag. Don't worry about this too much because normally this value gets auto-generated by your encoding software. So the example we're going to do today is going to auto-generate this for us. But just be aware that this is a required data element. The next data element that we must encode is the so-called T bit. So every RAIN RFID tag chip has a bit, a single bit, that gets encoded to either 0 or 1. If it is encoded as 0, that tells a reading system that the encoding is based on GS1 standards. If it's set to 1, that tells the reading system that the encoding is based on ISO standards. Well, if we remember what we're talking about, it's the RAIN Alliance ISO numbering system. So we're doing an ISO-based encoding, therefore we must set the T-bit to 1. The next data element is the so-called AFI. AFI stands for Application Family Identifier. This is an ISO-only concept, okay? It's a 2 hexadecimal digit value that gets encoded to your tag, and it tells a reading system, hey reader, This tag is encoded for the following application. Example applications would be airline baggage tags, or vehicle identification tags, or biologic sample tags like blood bags, plasma bags. In this case, we are going to encode hexadecimal alpha echo. That little 0x means that the value is in hexadecimal. So we're going to encode alpha echo as the AFI. That tells a reading system, hey, reading system, this encoding is a RAIN Alliance ISO numbering system encoding. The fourth data element, this is where that confusing term RAIN SIN comes in, CIN. The fourth data element, we must encode a RAIN issued company identification number. That tells the reading system who did the encoding, or at least who's responsible for the encoding. Okay, we're going to do more detail on what the RAIN SIN is later on. The fifth and last minimal data element is then going to be your identifier. In other words, your proprietary serial number. In the case of our printers, that's serial number that we put on the printer boxes. And you can put in there whatever else you want. You know, if you want to put in the color, have a field for the color or a field for the weight or whatever else you want. Normally, it's just your proprietary identifier. So those are the 5 minimal data elements that you must encode. Here they are in a terrifying picture. We're going to work through this picture and hopefully it's not too scary after we get through it. This picture is a schematic of Memory Bank 01. You may know Memory Bank 01 as EPC memory. That's the term that most people use. That's not really a correct term because EPC is specifically a GS1 term. Remember, we're doing an ISO encoding. Over in the ISO world, instead of saying EPC, people try to say UII. Means basically the same thing. EPC, electronic product code, UII, unique item identifier. Okay. This memory bank is your basic bread and butter memory bank where everybody who's encoding RAIN tags puts in a value and everybody who's reading the tags is reading this memory bank. Okay. This is where you put in your basic RFID encoding. I've divided it up into 3 chunks. On the left, the chunk is the CRC. Don't worry about this. It gets auto-generated for you. It's a check algorithm. I don't even think you can encode it, okay? So it gets generated for you. Don't worry about that chunk. The next chunk, this middle chunk, is the so-called PC bits or PC word. It's 16 bits, therefore it is a word in computer speak. 16 bits, and I'm going to come back to this in a moment. We're going to get into that in a little more detail. On the right-hand side, this is where you put your bread and butter serial number into the bread and butter memory bank. This is the portion of Memory Bank 101 that everybody uses to put in some kind of a number, okay? Most people are just putting a number in here and they think they're done. Well, that can create tag clutter, so we need to be careful. Jumping back to the PC bits, it is further divided into a bunch of little elements. The first element, the first 5 bits, is where you encode your length value. So if you remember, we had the 5 data elements that we must encode. There is length taken care of, okay? You're going to encode 5 bits here that will translate to a number. That number specifies the number of words, 16 bits, that a reader is looking for over in this portion of the memory bank. So we're not going to encode the length, or We're not going to generate the length value because our software is going to do it for us. That's the first one that's taken care of. These next two bits, 15 hexadecimal and 16 hexadecimal, don't even worry about those. Forget it. They get, under current standards, they get generated for you, or they're hard-coded to the tag chip. Bit 17, ta-da, this is our T bit, our so-called toggle bit. Remember, you set it to 0 for GS1 or 1 for ISO. We're doing an ISO encoding, so we're going to set it to 1. Then the last 8 bits of the PC word, or PC bits, are in the ISO world. This is where I put my AFI, my application family identifier. That is alpha echo in this case. Then, starting at bit 20 hexadecimal, the normal portion of the memory bank, we put in our RAIN company identification number, and then we put in whatever else you want, your serial number, and then any additional data elements. So these are the 5 data elements: your length, your T bit, your AFI, your RAIN SIN, and then your identifier. Okay, that is in a picture. Now we're going to do this actually in practice. You could, and people do, they make their own software to generate these encodings. Sounds like a lot of work to me. Alternatively, you could use some commercial label software. Bartender, Nice Label, Loftware has another product. Nice Label is now owned by Loftware. CodeSoft, Cybra, I think theirs is called Mark Magic, I don't know. So these are commercial label softwares that allow you to generate RAIN RFID encodings when you are printing and encoding a label, okay? I'm going to use Bartender. We're not favoring Bartender here, but I'm most familiar with it. And they recently did something very nice in their interface to support RAIN Alliance ISO numbering system encodings. So I'm going to exit out of here. All right. And we're going to go to Bartender. Now here we have Bartender. All of the label softwares look approximately like this, and they function approximately the same way. We have here, let's pretend that this is the label we put on our printer boxes, and this is where we put our printer serial number into the barcode, and we also print it as human readable text. We've been doing this for 30 years. It works okay, but now we want to leverage the power of RAIN and put an RFID encoding into this label as well. On the right-hand side, just as a reminder, I put down the 5 data elements that we must encode. The length, Bartender's going to take care of that for us and generate that automatically. The T bit, the AFI of alpha echo, the RAIN SIN, and then our actual identifier. I have here on Bartender my different label objects, like a barcode object, a text object, and I have this so-called RFID encoding object. This is not a Bartender tutorial, but I just want to show you what they're doing and how they do it. Okay, so I put down an RFID object on my label. As I have said, Bartender is going to take care of the length value for me. The next thing I need to take care of is the so-called T bit. What Bartender has done here, when you put down an RFID object, they give you 2 choices, EPC or ISO. If you remember, EPC is a GS1 term. So if I select EPC here, Bartender will automatically generate a T bit value of 0. If I select ISO, Bartender will generate a T bit of 1. We've now taken care of the length and the T bit. Now we need to do the application family identifier. When I select ISO in Bartender, Bartender pops up application and AFI. These are two ways of saying the same thing. They're just trying to make it user-friendly. Under application, what they've done is they've pre-programmed some common common ISO AFIs that you could use. Vehicle identification, airline baggage, and what they recently added, very nice, is the RAIN Alliance ISO number. So if I select that, Bartender auto-populates the AFI value with alpha echo in hexadecimal. Great, it's done. Then I have the last two data elements, the RAIN company identification number and the actual identifier itself. These two, again, go into our so-called normal portion of memory bank 01. That's what Bartender is set up over here for. I've created two data elements. One is the RAIN company identification number. I know this is small, but I have here a value that is TSC's own RAIN issued company identification number. That is in hexadecimal. I'm going to show you that in more detail later. So I put in my RAIN SIN, and then I have my serial number from my printer, and I would encode that. So now, if I hit print in Bartender, my printer is going to spit out a label that is printed with this serial number, printed with the barcode of the serial number, and I'm going to have a RAIN Alliance ISO numbering system encoding with that serial number. In our big warehouse, I can look for a specific printer. I can push a button and do an inventory count of all of our printers or all of our printers of a particular type, and so on. So I've just very easily converted our 30-year-old serial number label into a RAIN RFID encoding that includes that serial number, and the encoding is standards-based to avoid tag clutter. Let's go back here. So that was in practice using Bartender. A little detour here. I just want to get into what is the RAIN SIN in more detail. So as I've said, it's a company identification number, but in this case, it must be issued by RAIN. Okay. Now, it is not just for use with a RAIN Alliance numbering system encoding. It is a genuine ISO-based standard company identification number. So it can be used in any ISO standards encoding. You remember our silver cylindrical automotive part? The company that makes that part may want to get their company number from RAIN, and they do a different ISO encoding, the one that's commonly used for automotive parts over in Europe. They can use the RAIN issued company identification number. So it's not just for this numbering system, it's a genuine broad ISO company identification number. Not sure how much detail I want to get into here, but let's go to GS1 for a moment. In the GS1 world, they have a very similar concept. They call it a company prefix. Sometimes you'll see it as a GCP, global company prefix. It's a number that identifies that company. In the GS1 world, only one entity can issue those company numbers, GS1. So if you see a number and it's a GS1 number and you want to know what company that is, Nike, Adidas, Levi's, whatever, you can take that number, go to GS1 and say, what company is this? And GS1 will come back and say, that is Nike, that is Adidas, whatever. In the ISO world, it works a little differently. There are many entities that can issue company identification numbers. RAIN is just one such entity. Other entities include Microsoft, NATO, UPS, DHL, IBM. There are many, and I think there's about 50 entities that can issue ISO valid company identification numbers. Because you have a multitude of entities that can issue company identification numbers, the way you normally uniquely identify the tagging company in an ISO encoding is by making a two-part construct. Get my laser pointer back. You do a two-part construct. You have what's called the IAC, the issuing agency code, that tells a reader who issued this company identification number. And then you have the actual number. So if you want to find out who the company is, you go to this issuing agency and you say, whose number is this? Okay, that's a so-called normal ISO encoding. But with the RAIN Alliance ISO numbering system, we have a bit of an exception. You do not need to put in the IAC for RAIN. By the way, the IAC for RAIN is XRA. If I was the automotive parts company and I was tagging my auto parts with ISO 17360 standard, I would need to put this in there somewhere. But in a RAIN Alliance ISO numbering system encoding, which is the focus of today, I do not need to put the IAC in there. So when the AFI is Alpha Echo, that's our RAIN Alliance ISO numbering system, the IAC is not used. The SIN alone uniquely identifies the tagging entity. And as a final reminder, RAIN SIN encodings, no such thing, okay? Last slide here. This is just a screenshot from the RAIN Alliance website. This is a list of public RAIN SINs that have been issued. And I only have the first two listed, or two of them listed here. The list is about 50 long. There are other companies that have RAIN SINs, but they have selected not to publish them, okay? So if you get a RAIN SIN, and to do that, you would contact RAIN. There's a little web form you fill out. If everything goes all right, RAIN issues you with a company identification number. TSC, we filled out the form. That's my company. And RAIN issues a company identification number. It's this number here. But you will notice that that company identification number exists in different formats. RAIN will always give you at least this decimal version of it and a hexadecimal equivalent. They give you that hexadecimal equivalent because a lot of encoding software is set up to encode hex. So this is just making it easy for you. To convert this decimal number to the bits, according to the standards, is actually quite complicated. Okay, it uses a special algorithm. RAIN has taken care of that algorithm for you already, and they say, here's the hex equivalent. Sometimes you can get a text value of that number as well. So you could theoretically encode it using text characters as well. We have ours fancy TSC exclamation mark. But here's the hexadecimal value. Again, that 0x means hexadecimal. We should either have it or not have it in all of the entries. This is an oversight on our part. We're going to clean that up. So if you notice, ours was D4, D3, C3, 2, 1. Let's go back to bartender for just a second. And you'll notice that in bartender, for the RAIN SIN, I was using hexadecimal in bartender. There it is, D4, D3, C3, 2, 1. Okay. All right, that's that. So if you're interested in getting a RAIN company identification number to do your own encodings, you can contact me. Boom, there's my email address, or you can contact RAIN, or if you go to the RAIN website, you'll see the application form. Thank you. Well, back to you, Aileen.
Thank you very much, Chris. That was really informative, and we do already have some questions that have come in. So prepare yourself, Chris. In the meantime, anyone who has additional questions, you will find the Q&A tab. Well, it's towards the bottom of my screen. I don't know if it is on everybody's screen, but we're using the Q&A rather than the chat for questions. So, Chris, the first two questions are probably actually best answered by linking them together. So you did cover this to a degree at the beginning of the presentation. Advice on choosing GS1, ISO, or the RAIN SIN. And if already registered with ISO as an example, can the RAIN SIN also be used?
Okay. So how to select if you're lost in the wild and you're trying to figure out, all right, which numbering system should I use? On the RAIN website, you have to dig around a little bit, but there is a graphic that shows you a pathway to select your correct numbering system. But to sort of simplify, again, if you're already using GS1, go down the GS1 road. If you're already using ISO, go down the ISO road. If you're not using anything, then look around. What are other people in your industry and your application using? If they're using GS1, probably best to go down that road. If they're using ISO, probably best to go down that road. Finally, if you're just trying to do what we're talking about today, which is encode a proprietary number that you've been using for possibly decades, this RAIN Alliance ISO numbering system is the ideal solution. Cheap, easy, simple, and technically very efficient. I hope what was the second part of the, can I use, so if I already have an ISO issue, ISO doesn't issue the company numbers. If I already have an ISO company identification number that was issued by an entity, an issuing agency issued by somebody other than RAIN, like maybe Microsoft or NATO or IBM, can it be used with a RAIN AFI encoding?
Mm-hmm.
Out of the box, no. But you could still wrap it up. you always have to get a RAIN company identification number. Let me put it that way. So the out of the box answer is no, but you could wrap it up in a proper RAIN Alliance numbering system encoding. If you had a RAIN, if you also got a RAIN SIN.
Thank you, Chris. Also kind of a linked question. Are you aware of any systems that support both GS1 and ISO, and is supporting both standards something that your team, as in the RAIN Alliance working group team, would not advise to do?
I am aware of such systems. So I talked about automotive parts. Over in Europe, there's sort of a de facto consensus to use ISO numbering for the automotive parts. You come over to North America and we have a jumble. Some people are encoding using ISO numbering. For example, BMW has production manufacturing of their vehicles in the United States. They are telling their suppliers, put ISO numbers on your parts that you ship to us. But there are other automotive manufacturers or automotive parts manufacturers that are using GS1. And this is only because of history. So the automotive manufacturer, Ford, General Motors, even BMW, they do have systems that can read both tags. They have to set up the software so that it can decode both, and it's more complicated, more prone to error, but it does happen. I suppose sort of a related topic is, why are there two systems? And the answer is, there is no good answer. History. Okay. I think I
Thank you,
answered that.
Chris.
I hope so.
Yeah. One quite specific question. What's the maximum number of characters for the identifier?
Good question. There is no maximum number of characters. That's a long, see how I can answer this. So you have your identifier. Your identifier uses some particular character set. Could be numeric only, could be alphanumeric. It could be a hexadecimal serial number. You start with your character set. You have to convert those characters to bits using some algorithm. In general, the simpler the character set you start with, the fewer bits you need to encode each character. So hexadecimal, as a general rule, uses 4 bits per character. If you're just using decimal, there are different algorithms you could use, but it's a little bit less than 4 bits per character as a general rule. If your character set is full extended ASCII, you're probably going to need 8 bits per character. If it's standard ASCII, you can get by with 7 bits per character. So to answer the question, you start with your character set. You need to convert it to bits, X number of bits per character or group of characters times the number of characters you have to encode, and that tells you how much memory you need. So it can be infinite, but most sort of the maximum on tag chips in that memory bank is 496 bits. That's actually a GS1 standard. I think the ISO standards do not specify a maximum number of bits for the memory bank 01, but good luck finding a chip with more than 496 bits. In general, you want to make your encoding as small as possible. Put it that way.
Thank you. Another question, are current printers and readers in the market are able to handle GS1 ISO and the RAIN ISO encoding system?
Answer is yes and no. Yes, in that printers and readers, well, let's stick with printers first. On the printer side, the printer will encode to the tag whatever it is told to encode. This gets a little more complicated. So you can do anything with one of these printers, but you have to feed it data. You have to send data to the printer that the printer can understand. Let's take, in the ISO world, those automotive parts encodings. They use a specific alphanumeric character set. It's not ASCII. It's sort of a truncated alphanumeric character set. And they use a specific 6 bits per character. Now, printers do not yet support that character set converting to bits yet, but you could have your software that converts those characters to bits and then converts those bits to hex, and then you send hex to the printer and the printer can work with the hex. By the way, we're just about to release that 6-bit encoding so you can do it natively in the printer. Over on the reader side, I find it helpful to understand that the reader is really reading just bits, 0s and 1s. What the reader does with those bits, how it displays them, how it passes them to a host system is entirely up to the software level. So you can take those bits and convert them directly into your desired characters. If you look at your basic reader, it'll take those bits and convert them to hex and display hex. That doesn't mean that you encoded hex characters. It's just the reader's built-in software of displaying the bits that you get. If it does that, you can take those hex characters, send them up to another layer of software, and that software then converts those hex characters back to bits, and the bits back to your desired initial characters. I know that was a ridiculously complex explanation, but that's the way it is.
Thanks, Chris. We've got just a few minutes left, and I have a couple more questions for you. But anyone who still has a question that they'd like to get in, I would say type faster. Chris, the next one. It appears, this is, I think, from looking at the RAIN SIN register, it appears that a company can register multiple SINs. Is there a reason for that which can be shared here?
Sure, you can register multiple SINs, or you can apply for multiple SINs and you can get multiple SINs. I talked about GS1 company numbers, and I said, Nike has a company number. That's not really true. Nike probably has, I don't know, 10 company numbers. They might have separate little entities within their, whatever their legal structure is, and they might want to use this company number in this case and that company number in some other case. So yeah, you can have as many RAIN SINs as you want, and it's up to you what you would use them for.
Thank you. I think probably the last question, Chris, are there any other ISO-based RFID standards to wrap up proprietary numbers?
Yes, there are. So before RAIN developed the RAIN Alliance ISO numbering system, the ISO people did foresee this need to be able to wrap up, to enclose proprietary numbers. So they have some AFIs that were designed for this. However, if you dig into the technical details of those standards, they do not guarantee unique encodings. So those AFIs are sort of fading away and being replaced by what the RAIN Alliance has done with the ISO numbering system.
Thank you. Right, we are all out of questions, Chris.
I do see one. It says, odd question. Is it possible to theoretically create tag clutter intentionally? Answer, yes.
Okay, good. Chris, thank you very much. We're very grateful for your time and your expertise and your very clear explanations. As I mentioned, for all of our delegates, the slides and the recording will be posted very shortly on the RAIN Alliance website. If you go to our website and you want to get a SIN for your own company or your own product line or whatever makes good logic for your particular instance, then you will find it quite easily. So rainrfid.org, and if you just scroll down a little bit, you'll find a form that says request a SIN. So it's pretty straightforward. If you have any questions, please just feel free to reach out either to Chris here or to myself, in which case I'll probably just refer directly to Chris and the team, who is extremely knowledgeable on this subject. So thank you all very much. Thank you, Chris, and we'll see you all hopefully at our next Knowledge Series webinar. Thank you.
Thank you, everybody. Bye-bye.